Find the prime factorization of the radicand. Group prime factors to make perfect squares. Simplify. This is the simplest radical form. For example, we have the square root of 24 equals the square root of 2 times 2 times 2 times 3. So we can group those 2's into 2 squared and then 1 extra 2 and then our leftover 3. We can separate this part by itself out front in its own radical so that this and this will cancel, leaving us with 2 out front, giving us 2 times the square root of 6 because we still have a 2 times a 3 left over under the radical. For the square root of 72, we take 72, we break that down into 9 and 8. 9 breaks down to 3 and 3, 8 breaks down to 2 and 4, and this 4 breaks down to 2 and 2. So we have 3 times 3 times 2 times 2 times 2. So we can break that down into 2 squared times 2 times 3 squared. Therefore, we can put this piece and this piece under their own radicals, and that leaves behind 1 square root of 2. Then this cancels that, leaving us with 2 times 3, which is 6, times the square root of 2. For square root of 18, 18 is 9 and 2, which is 3 and 3. So 3 times 3 times 2 can be written as 3 squared times 2. 3 squared can be separated into its own radical, that leaving just 3 out front times the square root of 2. For the square root of 360, which is 360 is 36 times 10, 36 is 6 times 6, 10 is 5 times 2, so 6 becomes 3 times 2, 3 times 2. So we have 2 3's, 3 2's, and a 5. So we can write that out as 2 squared times 2 times 3 squared times 5. Then this piece and this piece can be brought out front with their own radicals so that we are left with just 2 times 3 out front, which is 6. And then we have a 2 and a 5 left over under this radical, which multiply together to 10.